Okay, let's take a look at exercise 35 in section 2.7. Here we have the graph of a function, and we want to use this function's graph to draw the graph of its inverse function. So one of the things that we need to understand is the reflective property of a function and its inverse. So that property basically tells me if I know a point on the function, I automatically have a corresponding point on the inverse. So we see here that there are a number of points that we can determine on this function. So let's look at this lower point whose x-coordinate is negative 1, 2, 3, 4, and whose y-coordinate is negative 1, 2, 3, 4. So this is a point on the function f. The coordinates are negative 4, negative 4. So all I have to do is interchange the x and the y to get a point on the inverse, the graph of the inverse. Now, since the x and y are the same, this point lies on both the function and on the inverse. So this is a point that the two functions have in common. Let's look at this middle point whose x-coordinate is negative 1, 2, 3, and whose y-coordinate is 1. So negative 3, 1 are the coordinates of this point. All I need to do to get the mirror image point, or we could call it the corresponding point on the inverse, is to interchange the x and the y. So the y of this point on f is 1, so that's the x of the point that corresponds to it on the inverse. The x of this point is negative 3 on the function f, so that's the y-coordinate of the corresponding point on f inverse. And let's look at this upper point whose x-coordinate is 2 and whose y-coordinate is 1, 2, 3, 4, 5. So on f, this is the point 2, 5. Interchange the x and the y, and we have the point 5, 2 on the inverse. So notice if AB is a point on f of x, then BA is a point on f inverse of x, which we write using this notation. All right, so that's the reflective property of a function and its inverse. So we basically know that negative 4, negative 4 is a point on f inverse. 1, negative 3 is a point on f inverse. And 5, 2 is a point on f inverse. So we can connect these three dots and have a graph of f inverse. So I'm going to take a minute and go into a sketching tool that will allow me to do this where my lines are going to be straight. Okay, so let's We know that this is a point common to both the function and its inverse. We said that since this point has coordinates -3, 1, that 1, -3 was a point on the inverse. And since 2, 5 was a point on the function, 5, 2 is a point on the inverse. So these were the points we had marked off. And let's actually connect these dots. And I'm going to draw the inverse in red. So the red curve is the graph of the inverse. So the blue curve gives me the graph of the function. And the red curve gives me the graph of the inverse. And we want to keep in mind that whenever I'm doing this, a function and its inverse form a symmetrical picture about the line y = x. That actually is the mirror which reflects the function about its inverse. So here's my line y = x, and that actually serves as my mirror. So y equal to x is my mirror. And the function and its inverse are reflections of each other about that mirror. So this is the power of the reflective property of a function and its inverse. If I know a point on the function, I'm able to get a point on the inverse, which is actually the mirror image of that point on the function. So notice any point that lies directly on the mirror is a point on both the function and the inverse, as this point -4, -4 is. Notice these are points that have the same x value as y value. Notice how the mirror image of -3, 1 is 1, -3. If y = x, the line y = x is our mirror. The mirror image of 2, 5 is 5, 2. So we get this inverse function, which is the mirror image of the function, if the line y = x is our mirror.